I need help for 7.35. Would you solve the problem for me?
Sure. The problem statement mentions that there is a concentric cylinder device based off the image right here. We need to create a dimensional analysis in regards to the variables that they do give us, theta equaling a function in regards to angular velocity, viscosity, a value of k, the two diameters, and the height of the cylinder. So our first step is to take this function and make each variable non-dimensional in respects to each other. Now theta is already non-dimensional, so that will be a pi group, and we're just going to leave it alone for the moment. So using all of these terms, we're going to write down what its units would be. So omega would be 1 over t, or t to the negative 1. Viscosity is force times L to the negative 2 times time. K, which is given in the problem set, is force times length. The first diameter will be in terms of length, the second diameter will be in terms of length, and the height of the cylinder will be in terms of length. So, the next set here is to pick which one of these we'll use to define the length term, the force term, and the time term. Looks like we're going to use the length, or the height of the cylinder, for L. For the force, it's a little bit more complicated, so I'm going to leave that blank at the moment. And the time, looks like we're probably using omega, but it's not as simple as that, so I'm also going to leave that blank. So if we have our first pi group as being theta, and we need to make our second pi group. Now the problem set stated that we needed to get theta in terms of omega, so we're going to basically non-dimensionalize omega in terms of all of the variables we have in our use. So omega, which is time inverse, will need to be multiplied by something else that has time, which is viscosity. So viscosity, which is F L to the negative 2 times time, well, the times are away, but now we need to get rid of the force and the length to the negative 2. So we know that the other term with force is the k term, so we're going to divide by that. And now the forces go away, but we still have a negative 2. So we're now going to times it by length cubed, so then all of these go away. So it becomes non-dimensional. So our second pi group is omega times viscosity L cubed over k. Now we still have two variables that we never used, which just means that our function will have ratios in regards to the diameters and the height of the cylinder. So our final non-dimensional equation will be this. Now in the problem set, pretty much all we're doing is just graphing omega versus, or theta versus omega, mu L cubed over k. So after taking these two and putting them into Excel using the given numbers that they gave us in the problem set for mu, k, length, and using this table for values for theta and omega, but we get this graph.
And the f is the slope of this graph, right?
Well,
Yeah.
yeah.
So in the Excel, we get the equation. It's like the slope is 2.98. Yeah.
Times 10 to the 3.
So we get the equation there, and just plug back in all the numbers, and we got the final
Answer as being 298 omega mu.
Yeah.
Okay, that makes sense.
Yeah.
Thank you.
You're welcome.